Have you ever paused to wonder why some buildings reach for the sky while others crumble to the ground? Is it the architect's vision? The materials used? The foundation? Or maybe, is it the combination of a solid foundation and a master plan? A robust foundation paired with a strategic blueprint is everything. Without these, even the most awe-inspiring skyscrapers can come crashing down. Just like in architecture, preparing for coding interviews demands a strong base. Too many aspiring coders jump into preparation without laying this groundwork. The result? They stumble when faced with complex concepts. So, how do you build this unwavering foundation? In today's video, I'm here to guide you through the essential steps to create a sturdy base that will elevate your coding journey. First up is the problem-solving mindset. Imagine walking into an interview, confronted with a challenging problem. Do you see it as an insurmountable obstacle, or do you perceive it as an exciting opportunity? This shift in mindset is where your journey truly begins. A positive mindset empowers you to face challenges head-on and encourages creative thinking. Embrace the struggle. It's not merely a hurdle, it's a vital part of your growth. Ready to explore the second pillar? It's mastering the basics. Think of these fundamentals as the building blocks of your coding knowledge. Without a solid understanding of them, constructing anything substantial will be a challenge. To master the basics, focus on the following areas. 1. Language fundamentals. Understand the core concepts, such as primitive and reference types, mutable and immutable data structures, short-circuit evaluation, control structures, iteration, string manipulation, and array operations, including matrices, sparse matrices, and multi-dimensional arrays. 2. Memory allocation. Do you know how memory is allocated when you create a variable or an array? Grasping the difference between static and dynamic allocation is essential. Static allocation reserves memory at compile time, while dynamic allocation occurs at runtime. This knowledge can significantly optimize your code. 3. Basic problem-solving approaches and techniques. Familiarize yourself with fundamental approaches, broad strategies that encompass various techniques for solving problems. For instance, when attempting to crack a password, people often start with a brute force approach, trying all possible combinations. Another essential approach is divide and conquer, that involves breaking down a problem into smaller subproblems, solving those subproblems independently, and combining the solutions to solve the original problem. Some of the approaches are so well defined for specific types of problems that they are often referred to as algorithms. Once you're comfortable with the fundamental approaches, it's time to dive into essential techniques that can elevate your problem-solving skills. Prefix, sum, two-pointer methods, memoization, and tabulation. Mastering these techniques is crucial for effectively tackling a variety of challenges. Prefix sum. The prefix sum technique involves pre-computing the cumulative sums of elements in an array. This allows you to efficiently calculate the sum of any subarray or range with just a simple subtraction. For example, it's ideal for determining the running sum of an array. Two-pointer method. The two-pointer technique employs two pointers to traverse a data structure, making it a powerful tool for finding pairs or checking conditions efficiently. Here are some key variations. Opposite traversal. Place one pointer at the left end and the other at the right end of the array, then move them toward the center. Slow and fast pointers. This involves two pointers moving at different speeds. Typically, they start from the left end, with the first pointer moving faster to help detect cycles or find specific conditions. Sliding window. This technique creates a window that shifts across a data structure, allowing you to examine contiguous blocks of elements. It's particularly useful for problems that require finding subarrays or substrings that meet certain criteria. Using pointers on separate array. This variation is used for tasks like merging to sorted arrays or finding the intersection of two arrays, where each pointer operates on a different array. Memoization. Memoization is an optimization strategy that stores the results of expensive function calls and reuses them when the same inputs occur again. This significantly boosts the efficiency of recursive algorithms by avoiding redundant calculations. Tabulation. Similar to memoization, tabulation solves problems by building a table iteratively, filling in values based on previously computed results. It's a key technique in dynamic programming, which tackles more complex problems systematically. With a solid understanding of these techniques, you're well prepared for the next steps in your coding journey. In my upcoming video, 5 Steps Master Plan to Crack Coding Interviews, I'll share proven strategies to help you excel in coding interviews. Thank you for watching, and I look forward to seeing you next time.